Okay, example 3. Before I get to that, let's get a few rules here. Actually, a few definitions. An inscribed angle has its vertex on the edge of a circle, and it opens up to an intercepted arc on the other end of the circle. And the intercepted arc is twice the measure of the inscribed angle. That's the property between this angle and this arc in degree world. Okay, so if this angle, let's say, is 38 degrees, then this arc is going to be 76 degrees. Okay? And again, that's if the vertex is on the edge, you double the angle measure. And also you can half the arc measure to get the angle. So if the arc were, let's throw these up, if the arc were 94 degrees, this angle would be 47 degrees. All right, so there's a relationship. We can go from the inscribed angle to the intercepted arc, or from the intercepted arc back to the inscribed angle. We have that relationship between those two numbers. Down here we have a central angle. Its vertex is at the center of the circle. Those are really the only two places where a vertex can be where there's any kind of properties. Either at the center, it's a central angle, or at the edge, it's an inscribed angle. If it's somewhere in the middle like this, nothing special. No properties, okay? But again, if we are exactly at the center or exactly on the edge, we have properties. The property for central angle and intercepted arc, they're exactly the same angle measure. So if this is 68 degrees, this is 68 degrees. All right? Here's one thing they like to throw at people sometimes. Suppose they did this. Use a different color here. Red. Suppose, down here, they gave you that picture there, and they said this angle here, let's say, is, let's go with 80 degrees. And they want to know how big that angle is. All right? If that's 80, that means this is 80. And if this is 80, that means this is 40. Or vice versa. Maybe they'll give you this angle and ask for that angle. So that kind of stuff happens sometimes. Once again, properties. The properties exist. Are properties difficult on their own? No. When there's 500 properties that you're supposed to know that you've ever learned in your entire life, is it hard? A little bit. Okay, so make sure that as you do these properties, don't just say, this is easy, blah, 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 just get the answer. Really think through what the property says. Identify things in the picture. That's an inscribed angle. That's an intercepted arc. That's a central angle. When you see those pictures, do some, in your brain, thinking about what things are called and what properties are associated with those things, and then they'll stick with you a lot longer. All right? And then when you get a list of 500 properties, they're pretty much right in your memory bank. So, example 3, here we have a picture. It says find x. So again, mentally what I'm doing in this problem as soon as I see it is I recognize this is an inscribed angle. And then I start thinking about my inscribed angle rule that says the inscribed angle is half as big as the intercepted arc. And I look and say, well, there's the intercepted arc right there. So then I can start labeling stuff. So they didn't tell me to find this, right? They didn't say, hey, find the blue piece. But if that's 40, that's 80, that's pretty easy, and it wouldn't be very difficult for me to mark up my paper with that information. Anytime you look at a figure, you can fill something else in that figure, give yourself more information to work with. It's probably beneficial. So it would be worth doing. So again, inscribed angle, it's half the measure, so 40 times 2 is 80. That's how big the arc is. The next thing I think about is I see degree measures involving a circle. What do we know about a circle and degree measures? 360 degrees all the way around, right? And would everybody agree if I took the red arc and the green arc and the blue arc, I would get all the way around the circle, right? Yeah. So I can use that property to create a good equation about x. 5x plus 80 plus 7x plus 40. The three pieces, 5x, 80, and 7x plus 40, make up a whole circle, so that equals 360. Just like that, I took a picture. I had properties associated with that picture to create myself a good algebraic equation. And then I simplified 12x plus 120 on this side is equal to 360 on that side. Move 120 over, so we get 12x equals 240. We divide by 12, we get x equals 20. The directions said find x, right? So that's the answer. Other directions they could have given me. Find the measure of this arc. What's the measure of that arc now? 100. 100, because 5 times 20 is 100. How about this one? 180. 180. Give me one reason why it's 180.
Because it's half the circle.
do you know it's half a circle because it looks like it?
No, because it's a inscribed angle.
The lines that mark it.
Okay, this looks like a diameter, but it wasn't told to be a diameter. It doesn't. There's no circle mark, a center mark, so we can't assume that to be a diameter. So we can't say it's half a circle because it looks like it. It is. You're right. But that's not one of the justifiable reasons why that's 180. Okay. Okay. We've already used up from here to here 180 degrees, so there's 180 degrees left. That's one way. The other way, 7 times 20 is 140 plus 40 is 180. Both those ways. It looks like a half a circle. It does, but again, unless they give a specific, if they mark the center, let's say C is the center of the circle, now that is a diameter, then absolutely it's half a circle, you can go that route. Okay, but you can't just say it looks like it, so it is. Maddie?
Can you re-explain how you got the 80?
This 80.
Yeah.
Okay. Going back to this picture here, we have an inscribed angle. The relationship between an intercepted arc and an inscribed angle is this is 2 times as big as that. So if this is x, this is 2x. So you just double whatever that is to get that. So looking at this picture, that's what we got here. This is an inscribed angle. Its vertex is right here on the edge of the circle. That's half as big as that, so 40 times 2 is 80.
Okay.
All right? And again, that's something that you want to look for in circles because intercepted arcs happen a lot with inscribed angles. So this relationship occurs a lot of times when you see a circle. The other relationship that happens quite often is the central angle picture. In that case, they're equal to each other, 80-80. All right, 40-80. All right? Any other concerns?